cell cycle is a cell that's gotten to a certain point in its life cycle, and it's decided it's time to divide. Now, when a cell divides, a couple things gotta happen. Okay, number one, we gotta divide up the stuff in the nucleus. That's this part of it over here. Okay? If something isn't in the nucleus, what's left in the cell, Andrew? What's left other than the nucleus of a cell?
Bless you.
What's outside the nucleus of the cell? Remember the cytoplasm with all those little organelles in it we learned about in chapter 7? Okay. So we also got to divide that stuff up too.
The four phases
That's
would be the
kind of the
embryos.
rest of the cell cycle. All right. A cell spends most of its life, and the cell it spends most of its life in the G1, S, and the G2 phase. Now these are in your notes, by the way, right? We have this in our notes. Got it in our learning packets with the chapter. So we've gone over it. We're just kind of those three phases, G1, S, and G2, are called interphase. That's where a cell will spend most of its life. As it's growing, that's when the cells start to grow. First phase, it's doubling its DNA. Third, it's getting ready to split that DNA up. And then finally, it splits the DNA up, and then the cytoplasm. Okay. These three phases here, G1, S, and G2, are called interphase. That's where a cell spends most of its life. Okay, now again, make this personal. This is the cells in your body and my body. It's not just something, in a textbook. What's going on right now? Anybody get a cut on their hand recently?
On my neck.
Anybody get a scrape on them somewhere? All right. Anybody got a sore on their body someplace? Don't show me.
I got a mole removed.
All right. Yeah, we all do. So we're constantly having to make more cells. Anybody still growing? I'm going more this way.
Yeah, really big, huh?
You guys are some of you still going that.
I keep eating you.
Not really.
So we're doing this. Yeah, right. This is again. This is
It's going on YouTube now.
This is not just out there in space somewhere. This is going on with us.
You're so weird.
All right. Let's use this outline in front of you. The four phases of the cell cycle. There they are, right there. You ready? Four
Yes, I
phases.
was right.
The whole thing now, the cell cycle. This can be confusing because there's also four phases in mitosis over here. But the whole thing has four phases. There they are. G1 phase, S phase, G2 phase, and then what's the fourth phase?
M phase. And phase. Yeah.
Okay? Now listen, I am not going to expect you to know everything that goes on in the four phases of mitosis. We don't get asked that anymore in the regions, but you still are going to have to know that mitosis starts off with prophase, then moves along to metaphase, anaphase, and telophase, to divide up the material inside our cell. The goal here, by the way, I don't know if I've said this enough, the goal here is to start with one cell and end up with two identical smaller
G1
daughters.
phase.
That's the goal.
G2
Right.
phase.
That's the goal. If you did any of those things I just mentioned, countries,
And S phase.
bruise yourself, are growing, whatever it might be, so you need more cells. And this is the tape. This is the way of doing it.
I'm kidding.
Number two, what happens when the cell copies its chromosomes? That's another term for DNA replication. If I said, okay, your body cells have 46 chromosomes in them. I need two that are identical. So how many chromosomes does each of those two new daughter cells need? We started with 46. How much does each of the two, Joel, the two new ones, how much do they have to have? We want them to be identical to the original. They gotta have 46, don't they? They gotta have 46. So that means we gotta double everything. And doubling everything is the same as doubling chromosomes as well. All right, so number two, what happens when the cell copies its chromosomes? It makes an extra set. That's all we need for that, just makes an extra set. Okay.
What's the next two bases
Yep.
in the DNA?
Of the DNA double helix, yeah.
Did
No.
you put together incorrectly, like the letters, can they be like,
You're like being clairvoyant, you're looking into the future, you know what that means? Yes, that's coming up in the next unit. You know what we call that? When instead of in DNA replication, instead of making an identical copy of our DNA, there's a little mistake in there? What do we call that? I showed you two of them yesterday in video class.
mutation?
Mutation!
Woo!
Yes. James, good?
He's
All right,
so
good.
excited.
All right, yeah, those are mutations. When the body incorrectly copies its DNA. And is that good for the most part, do you think, based on what we saw yesterday?
Probably not.
Not a good thing. By the way, if you weren't here yesterday, we saw two short clips yesterday. One was a young lady who, because of something in her DNA, they're not sure what it is. Only a dozen people have ever diagnosed with it. Isn't able to feel any pain.
And the other one.
Now, everybody says, gee, that sounds good to me, but is it a good thing, really?
No.
No. When you feel pain, nobody likes it, but it tells us something's wrong. Yes, sir.
Going back to that little 20-year-old,
If you can't feel pain, like what if she has like?
when she's so small, like, her heart and stuff starts to get bigger, right? Wouldn't it like,
Well, no. I don't know if you heard that part. And here's the second mutation, by the way, that AC is referring to, okay, in case you weren't here. This girl was born normal. She developed normally, grew normally until she was about 2 or 3, and then boom, stopped. Everything stopped. Okay, her internal organs stopped growing, her external body stopped growing, her brain stopped developing. So she's now 20 years old, and how old did she look in that video?
4.
3.
Yeah, she looked like a toddler. She couldn't walk, she unfortunately couldn't talk.
I thought she was cute.
Very, very difficult.
She's older than you.
But here she is, 20 years old, sitting in a baby stroller.
She had a cute little
She
baby
was
face.
20 inches long and weighed 16 pounds. Now, she had something wrong with her DNA, didn't copy right at some point of development, missing a sequence of those nucleotides you mentioned. And those nucleotides control normal growth, but they're missing in her. Okay? And she's the only one ever diagnosed with that particular mutation in the history of genetics. Weird. Okay? But that, you know, we just throw these words up here as DNA replication, like it's a piece of cake. DNA replication, as we learned, it is an incredibly complex and amazing that it ever works, in my mind anyway, process. But we'll get to that. And number 3, I want to do this one and then move on. What happens during cytokinesis? There it is right up there. Okay? Well, this is the cell division part of it. You know, the cell is grown, replicated in DNA, is getting ready to divide.
Divides into
Now it's
mitosis.
dividing. So up here it's dividing prophase, metaphase, anaphase, telophase. It's dividing up the nuclear material. Cytokinesis dividing up the cytoplasm, just like the word cytoplasm, cytokinesis. Okay? I also put that in your objective sheet.
I'm on awake.
Okay? So what happens during cytokinesis? The cell divides up its cytoplasm.